So guys, in our last session, what we have discussed? We have discussed the CI pipeline. So what is exactly that CI pipeline does? So whenever we push our code to the main branch, that pipeline will create a Docker image and then it will push that Docker image to the Azure Container Registry. And after then, the pipeline is stopped. Means what? Now the application is not yet deployed anywhere. So we are only creating the Docker image, storing that Docker image into the Azure Container Registry. But that Docker image is not being used by anyone else to deploy the application. So in this session, what we are going to discuss? In this session, we will extend the pipeline by implementing the CD part. So CD part means continuous delivery. So what exactly we are going to implement? Now, whenever we made some changes to our application, and whenever we push that changes to the main branch in the GitHub repository, then that workflow or GitHub will do the following thing. What are the things that is what we are going to do? We are means that workflow what we will create, it will build the application. I mean, whatever the changes, it will test whether everything is fine or not. Then it will create the Docker image. It will push that Docker image to ACR. Then it will connect with the Azure Kubernetes Service. Then it will update the Kubernetes deployment file. And then it will perform a rolling update. And then right, it is going to verify the deployment, whether the deployment is successfully completed or not. So at the end of this session, every successful commit to the GitHub repository will automatically deploy the latest version of the application to Azure Kubernetes Service. Clear what we are going to develop? So basically, we are going to implement a complete CI/CD pipeline. So we are not going to stop after the CI part. We are also going to implement the CD part. So what are the role and responsibility of CI and what are the role and responsibility of the CD? So in the CI, so basically, technically, if you speak, we are going to create a workflow with two important jobs. One job, that is the CI part. Another job is going to be the CD part. So in CI, what we are going to do? We are going to basically check out the source code. I mean, downloading the source code from the repository, installing the required NuGet packages, building the solution. If any unit test you have written, those unit tests it is going to run. Then it is going to build the Docker image. It will tag the Docker image with the latest OS, that SAM, or whatever the commit, that information. And finally, it is going to push that Docker image into the Azure Container Registry. That is what we are going to implement as part of the CI and exactly at what we implement in our last session yesterday. So once the image is available in ACR, then our CD part is going to start. So this CD part will have a dependency on CI. So once the CI part completed successfully, then only the CD part is going to start. So what exactly the CD part is going to do? Now it is going to connect with the AKS cluster, so that Azure Kubernetes Service. Then it is going to apply the Kubernetes YML manifest. So basically, YML manifest means what? So we are going to have a different manifest file. One is namespace, another one is deployment, another one is a service. So in this case, it is going to update the deployment file. So basically, deployment file means what? Now, whatever the latest image, right, we push to Azure Container Registry, it is going to update the deployment file with that particular image, and then it is going to start the rolling update, and it will wait for the rollout to complete. And then once the deployment is done, it is going to verify whether the services is running, whether the code is running, right, everything is working as expected or not. So in simple word, what you can say, CI produces a tested and versionized Docker image. That Docker image is ready. CD deploy that Docker image to Azure Kubernetes services. Clear or not?
Yes, yes.
Yeah.
So now what we are going to do, we are going to prepare the Azure for AKS CI/CD pipeline. So basically, whatever the application we develop and whatever the CI pipeline we develop, whatever the resources we developed in our last session, we are going to use those things. Apart from that, whatever is required, that's what we are going to create, right? So these are the resources which we already created. That is the resource group. We have already created this Azure Container Registry. That login server URL is this one. Okay, let us try to prove this thing, right, whether this thing we have already created or not. So basically, if you go to the container registries, then you should file one container. So this container we have already created, and you can see this container is created inside a resource group, right? That resource group is nothing but this one, RG product management Docker. And then we have also created that login server URL. You can see this is going to my login server URL, ACR login URL. And here you can see, right, if you go to services, and here you will see repositories, and it also create one repository. You can see product management API. So that is going to be my Docker repository. And within this repository, you can see some images are also stored. So that what we have already created. Apart from this, we have also created one managed identity. So we have also created one managed identity that is being used as that is going to be used by GitHub Actions to communicate with GitHub. So not only we create this managed identity, we have also stored the federated credential. So what do you mean by federated credential? Now this managed identity is going to be used by which repository? Going to be used by which branch? What is that repository ID? What is that user ID? So those informations we have also stored. So that's what you can see. This is the federated credential and this is the subject body. So this information we have also stored. So, and ACR permissions to manage the identity. We have also given the ACR permission, Azure Container Registry. So if you go to this one, and if you go to access and control, then if you go to role assignment, then you can see we have this user subscription. Okay, not here. Okay. Okay, so basically we have given the ACR permission for the managed identity, Azure Container Registry. Okay, that's fine. So now what we are going to do? We are going to implement the remaining part. So before implementing the right, or you can say before implementing the complete CI/CD pipeline, or before creating the Azure right, AKS, or you can say cluster, first of all we need to understand the identity that is being used by the pipeline. So basically, in our application, we are going to use three different type identity. What are these identity? One is managed identity. That what we have already created, right? That managed identity we have created here. So this is going to be our managed identity, OIDC, MIC, product management API. And then, right, we need to give some permission to this managed identity. We have already given permission, right, for the ACR. That is fine. But now we also need to give permission to this managed identity so that, right, we can also perform the deployment activity. That GitHub should have access to this, what I can say, a case, or you can say cluster. And within the cluster, it should some perform some update operation on the deployment YML file. Why? Because we want to update that ready image which is being used to deploy the application. So basically, at this point of time, we need to give permission, four permissions to this identity. What are these permissions? Container registry repository writer, then write contributor and data access configuration manager, cluster user role, and RPAC writer. So what is this role? This role means it gives permission to push and read Docker images. So he can push Docker images and read, and already we have given, and he can read the Docker images. So this role is required to perform the required ACR authentication. So basically, using OIDC, right? We need to right that GitHub action needs to communicate with this ACR. So for that purpose, it needs to be authenticated this particular identity, and so that is the reason why we are giving this role to the identity. Apart from this, these two are we have already given in our previous session. So today what we are going to do, we are going to enhance that with these two user roles. One is Azure Kubernetes Service clustered user role. So this is basically used to get the AKS kubeconfig file. So AKS kubeconfig files means what? It will download the right cluster configuration. And this role is required because we want this identity to update the deployment, to update the service, and that is the reason why we need to give this role. So basically, whatever the identity is being used for doing these operations, that identity needs to be associated with these four roles. We have already created the identity, and we will see whether all these four roles are already assigned to the identity or not. If assigned, that is fine. If not assigned, then we will assign. Clear? Clear or not?
Yep.
So second identity, what is we are going to use is a kubelet identity. So earlier, right, what I have mentioned, now when you are working with the Azure cluster, right, Azure Kubernetes Service cluster, two identities are being used. One is clustered identity, which is going to manage the clustered level operations. And that is being generated by automatically. And another one is a kubelet identity. Again, this identity is also going to be generated automatically, and this kubelet identity is basically used at the node level. Node level means it is going to be worked with the right worker nodes. Worker nodes means what the main operation of this identity is to pull the Docker image from Azure Container Registry and then deploy the application as a container within the code. So basically, this kubelet identity, what is already being generated automatically by Azure, we need to give this permission. Azure Container Repository Reader. Repository Reader means pull the private Docker image. So basically, we need to give permission to this identity to pull the Docker private Docker image from ACR. Then another important thing that what you need to understand is a developer or a administrator identity. So as a developer, as the owner of this Azure portal, I also need to access a ACR. I also need to access a AKS. Everything I need to see. If you are giving right permission, then what are the permissions? So contributor, a role-based access control administrator, Azure Kubernetes Service clustered user role. So these are the different roles. This is optional, right? If you are providing permissions, that is fine. And even if you remember, we have assigned these two roles because we want to view the right Azure Container Registry and the repository inside the registry, and these roles are required for the Azure Kubernetes Service. So basically, whatever the service Azure Kubernetes Service or AKS cluster we are going to create, we need to manage the resources, we need to manage the role assignment within that cluster, right? For that purpose, that admin needs to be assigned with these four roles. So now let us check, right, what permission does the developer or administrator needs. So resource management permissions. So you need to give the resource management so that the admin can manage the cluster settings. He can start the cluster, stop the cluster, scale, update, everything. So this role is important. Then role assignment, access control. So basically, what exactly it means, the admin should give access, right? For example, right, who can do what operation, right? That role assignment needs to be done by the admin. So we need to give this permission. And Kubernetes access permission. So basically, if you want to communicate with a case, then this is required for the communication purpose, and this is required for doing operation within the Kubernetes services. So it will give access. I mean, it will log into Kubernetes service, and this means he can perform operation on the services that is available within the Kubernetes. So these four permissions we need to give. Clear?
Yeah.
Yep.
Yeah.
Yes.
Second. Now let us proceed and implement this first of all, step by step. We have already discussed to work with the Azure Kubernetes Service, what all register right or providers should be installed. So these are the different provider. They must be registered within your subscription. So how you can verify? Go to subscription, right? For example, this is going to be my subscription, and I have only one subscription. Open that subscriptions, and within the subscription, go to the settings section, and here you need to figure out right register providers. So resource providers, and just check, right, one by one, check all these resources and see whether that is registered or not. So like this. So similarly, they need to be registered. So these are the provided. Please ensure all these providers are registered. If not registered, then you can select, and for example, this is registered, this is not registered. So select this one and click on this register button. It will register that the provider. That's fine. Now Now we need to verify the existing ACR and Docker image. So how you can verify? Now existing ACR and Docker image means you need to go inside the container registries. So go to the container registry. This is the ACR that what we have already created in our previous session. Go inside the services and repositories. And within the repositories, you should see the image tag. So that means what? That means our ACR is ready. And within the ACR, the Docker image is also ready. So that is the first thing. So once this is fine, and whatever we discussed till now, this is what we have already implemented in our previous session. So basically in the previous session, we created the ACR and using the pipeline, we push the Docker image to the ACR. Now, what is the important part or what we are going to implement the CD part? CD part means continuous deployment. Where we need to do the deployment within the Azure Kubernetes Service. So first of all, if I'm going to use Azure Kubernetes Service, what I need to do? I need to create a cluster. So how to create a cluster? Now for creating a cluster, we need to use Kubernetes services, right? So go ahead and search Kubernetes services. This is the option that what you need to select. And currently you can see there is no Kubernetes services. So that section is empty. Select here and select a Kubernetes cluster. So we are going to create a cluster. So now here you need to provide the details. So what is the subscription? We have already known there is only one subscription. That is the reason why that is selected by default. And in this case, this is the resource group that what we created in our last session, RG product management Docker. So that resource group I need to select. And this is for the testing purpose, not for the production. So that is the reason why I'm using dev text so that the cost is going to be very less. Kubernetes cluster name, this is important. So that name you need to provide, right, any meaningful name. I'm going with this option, AKS product management cluster. So you can give any name. This name is going to be unique, right? This is going to be unique within the cluster. So give the name AKS product management cluster. Region, Central India is fine. Fleet manager not required. Availability zone is not required. AKS pricing, you can go with this free option. Enable long-term support is not required. Kubernetes version, that is the default version. I'm happy with this default version. And right, remaining default option, you can go. Here from the authentication, what authentication I need to use? I need to use this one, Microsoft Entra ID authentication with the Azure RBAC. So this is what we need to select. So basically Microsoft Entra ID is the authentication, Azure RBAC, that is going to be your authorization, role-based access control. So this is what you need to select. So once you select this thing, then go to the next tab, that is the node pool. And here you, I'm not interested for the auto provisioning. I mean, I don't want to generate automatically the node pool. So I want to use this node pools, right, which is provided system node pool. So from here, we need to update the node pool settings. So the node pool name is going to be agent pool. If you want to update, you can update. Mode is going to be system, the default mode. Operating system, I want to use Linux. This is the image that what I want to use, Ubuntu Linux. And here I don't want to select any zone, so no zone. Enable Azure support spot instances, no. So choose the node size. I'm happy with this default node. So 4 CPU, 16 GB memory. I want to go with the manual scaling and node count is going to be 2. So this node count 2 is means what? It is going to generate how many virtual machines? Guys, tell me. How many
Two,
virtual machines?
two.
So two virtual machines it is going to create. And then from the optional settings, maximum ports per node. So maximum 110 nodes means what? Maximum 110 instances of an application can run inside a single node. Enable public IP per node. No, I don't want to use this public IP to be shared to the client. So in that case, we are going to create a service. That service will provide the public IP. So I'm not going to create the public IP for each node. Maximum search default 10%. So 10% means what? Now by default, it is going to generate that many number of additional node, right? I mean additional port before right stopping any existing port. So basically that is available for the rolling update. Maximum unavailable 0 means what? Now it is not going to stop any existing port whenever it is going to do the deployment, right? So I'm not providing any label or any tent. So whatever the default option, right, that is fine. Click on the update button. Then click on this review and create. and then it will validate the configurations. If everything is fine, then you can create the cluster. Validation will take some time. It is going to check whatever all informations we provided, whether those informations are correct or not. If you correct, it will fine. It will give you the overview what you selected, and finally click on the create button. So once you click on the create button, what will happen? Now that cluster is going to be created, right? So once the cluster is created, then only we can create the services, right? Now, now we need to understand the right identities. So, as I mentioned earlier, whenever you are working with a cluster, there are two types of identities being generated automatically by the Azure. One is a clustered identity, and this clustered identity is basically responsible for what operations? Now, for cluster level operation. So, cluster level operation means what? Now, load balancer configuration, how to configure the public IP network communication route to disk, how you are going to store the data. So, that is what it is going to do. And what is kubelet identity? It is basically for the worker node configuration. So basically, worker node means what? Physical, your virtual machine. Inside the virtual machine, whatever the right, what I can say, deployment activity is going to be done within the pod. That is what going to be managed by kubelet. Means what? Now the main responsibility of this identity, pull the Docker image from ACR and then create the container within the pod. So this is for cluster level operations, and kubelet identity is for worker node level of operations. Right? Worker node level means what? Now it will pull the Docker image from ACR and then run that Docker image as a container within a pod. Clear? Clear, guys? Okay.
Yep.
Now let us
Yep.
try to understand, right? Now let us try to understand where this kubelet identity is created, and right, and let us verify how it is going to be look like. So kubelet identity is very right, created. It is created as an infrastructure resource group. Okay, so let me go to my cluster. So still deployment is going on. Once the deployment is done, then only I can show you the kubelet identity. So what is the step? The step is you have to open your cluster. Within the Kubernetes service, you need to select your cluster. You have to go to the settings and the properties section. In this property section, you need to figure out one resource group. What is that resource group? That resource group name is going to be infrastructure resource group. This is also known as the node resource group, and that resource group name is going to be something like this. What is the structure? MC, right? Then whatever the name you can see here, right? What I can say, resource group name. For example, MC, that is the name which is going to be start with right, managed resources. I mean auto generated resource group. RG product management Docker. This is going to be my resource group name. And then the cluster name what we created is a AKS product management cluster. And finally, the region where this I mean where this cluster is created, that is Central India. This is going to be the name of my resource group, right? So let me see whether the deployment is done. No, still it is going on. Kubernetes services. Okay. Now, if you click on this one, it will open my cluster. Right, within the cluster you have to go to the settings section. So there is a section called settings, and within the settings section you will find something called properties. Click on this properties. So once you click on this properties, you can see one resource group. What is that resource group? Infrastructure resource group, auto generated, right? And the name you can see MC, then RG product management Docker. This is the resource group name where this cluster is created. AKS product management cluster. This is the cluster name. Central India. This is the region where this cluster is being generated. So this is going to be my right. What I can say, infrastructure resource group. So then what we need to do? We need to go to the right. Once you figure out this, this is going to be my resource group. Then open the go to the resource groups, uh, resource, open resource groups, and in resource group, did you figure out that auto-generated resource group? Is this available here along with your Docker RT product management Docker? You can see this resource group is also available. So open this resource group. So once you open this resource group, right, then you will find one managed identity. That name is going to be AKS product management hyphen cluster agent pool. This is nothing but your kubelet identity. So kubelet identity, clustered identity, both are only managed identity. And in this case, you can see this AKS product management cluster slash agent pool. This is going to be my, right, what I can say, kubelet identity. Clear, guys? Clear?
Yes.
So
Yes.
open the kubelet identity and copy the client ID, copy the subscription ID value, and also copy the object principal ID. So this is nothing but your kubelet identity information. Clear?
Yeah.
Clear or not?
Yeah.
So now, so this kubelet identity is, what is the role of this kubelet identity? What exactly it is going to do? Like the managed identity we created, that will be used by GitHub
Azure
Actions to
services.
communicate with Azure. So now this kubelet identity, what is the role of this kubelet identity? It is going to be used by which? It is going to be used by cluster plane or worker node?
The nodes.
Worker node.
Work,
So
worker.
then what is the purpose of this right kubelet identity? What exactly it is going to do within the worker node? It is basically going to pull the Docker image from Azure Container Registry. Then it is going to create the container. Then it is going to run that container inside a pod. Am I right?
Yes.
Right. So basically, what exactly it means? It means we need to give this kubelet identity permissions to pull the image from ACR. Are you getting my point? So this kubelet identity, what is generated by system, this identity should and must have permission to access the image from ACR. And for this purpose, what role we need to give to this kubelet identity? Container registry repository reader. So it will read the image from the, right, what I can say, container registry. It will only read the image. I mean what? It will pull the Docker image. But it will not push the image. It will not delete the image. It will not do any changes to the image. So this particular role we need to give. Why? Because here we are not going to do any operation with the image. Our main objective, only pull the image. Once you get the image, you can deploy it. We are not going to do any kind of changes to the already pushed image. So that is the reason why whatever the kubelet identity we have, we need to give this permission. Why? Because we need to pull the image. So how we can do this thing? Now for this purpose, from right this kubelet, we need to give this permission. So basically, what exactly it means? It means this particular kubelet identity should have permissions to pull the image from Azure Container Registry. Am I right? Where it will pull the image? It will pull the image in the Azure Container Registry. So what you need to do? Open the container registries. Container registry. Go to this container, and here you can see access control. And in access control, you can see role assignment. Currently, right, these are different roles they have been assigned. But now, what is important? Add role assignment. So in the add role assignment, what role you need to search for? You need to search for container registry repository reader. Search this role, select this role, click on the next button. And this role we need to give to whom? We need to give to the kubelet identity. So if you want to give a particular role to a identity, then this option I need to select, or I need to select managed identity. Which option I need to select?
Manager.
Managed identity. After selecting the managed identity, which identity, that what also we need to select. Then in that case, what you need to do, we need to click on this select members option. So here Azure subscription, and here we need to provide user assigned managed identity, right? And from this user assigned managed identity, you can see these two identities. So from these two, which one I need to select?
First one.
First one, because this
First,
is, you can see RG. This is the OIDC, and this is the AKS product management cluster agent pool. This is the identity that what we need to select. So select this one, and then review and assign, again review and assign. That means we have given permission to the kubelet identity, pull the image from this Azure Container Registry. Clear, guys?
Clear.
Okay. Why we have given permission? Is that clear?
Yes, sir.
Yep.
Yes, sir.
Okay. So now if you want to verify a role assignment, right, you can also go to this one and select this one. And from this one, you can see, these are the user who have access to this particular role. That means the user currently logged in user, some unknown user, I don't know what is this, right? And this is what we just created. So these three user having permission to access the image from this registry. That's fine. So now we need to give AKS permissions to the existing CI/CD managed identity. So basically, what exactly it means? It means the Azure, the CI/CD pipeline should have permission to what I can say. Uh, to push the image and to deploy the application. So basically, already we have created one identity. It is already necessary ACR write permission. So for AKS deployment, we need two additional role. What are these role? We need to give this two role permission. One is clustered user role, another one is RBAC writer. So what is this clustered user role and why we should give this role right to this particular managed identity? Let us try to observe. So this role allows the managed identity to obtain the AKS user config. Without this role, the identity may authenticate with Azure but fail when requesting the AKS cluster credentials. So what exactly it means? It means using the Azure pipeline, we need to communicate with the what I can say. Okay, so using the kubelet command, kube control command, we have already discussed. Using the kube control command, we need to do operation with the cluster. So for that purpose, first of all, I need to install. I need to install the configurations. So that once the configuration is updated within the kubeconfig file, then only that operation, that communication is going to be possible. So basically, this role means what? We are giving permissions to this managed identity so that it can download the credentials which is required to communicate with the cluster. So how we can give this permission? The process is going to be same. The process is going to be same. Now tell me, this is one of the role. So we need to assign this role to whom? We need to assign this role to, let's tell me, to the managed identity. For what purpose? To download the AKS credentials. Then means what? We need to open the Kubernetes services. Open the Kubernetes services. Open the cluster. Go to the access control tab. Select this add role assignment. Select this role. Which role? Clustered user role. So this is the cluster user role. Click next, and this is managed identity. To which user we need to give this permission? To the to whom we need to give kubelet identity or the identity what we just created.
Clear.
So kubelet identity is not meant for what I can say downloading the credential. That is only meant for pulling the image from ACR. So in this case, what we need to do, the system or the user assigned identity what we created. In this case, this is the AKS clustered, kubelet identity, and this is the user assigned managed identity. So this user assigned managed identity we need to select, review, and assign the role. And in the same manner, right, what is the next identity we need to give? Azure Kubernetes Service, RBAC writer. So this is another role, but also we need to give access to the identity. Why? Because that managed identity needs to do the deployment, needs to do the deployment, needs to perform do some operation on the replica set, pod services, config maps, right? Many operations we need to do. So to give permission, so we need to give permission to those we need to give the permission to Azure Kubernetes services so that the managed identity can do operation on these resources. So this is very, very important. So first one, what we given, that will for downloading the credential. Once the credentials are being downloaded, then we can do some operation. We can update the deployment. We can update the service. We can update some configurations. We can update the secrets. So for that purpose, that managed identity should have this particular role. So let us proceed and do the same thing one more time. Select this role, Azure RPA Service Writer. So this is the role. Click Next. Managed identity. Select this one. Select the user assigned. Select this OIDC. Select this one. Review and assign. So once this is done, right, then if you want, you can give permissions to the developer, right? As a developer, what all operations we can perform. So we need to give this four role: Azure Kubernetes Service clustered user role. So this is for obtain the user config file. I mean, from the what I can say, from your command cell, if you want to communicate as a, I mean, from your user, from your own account, if you want to do some operations, then you need to again you need to use these roles. This is very similar to this role. You can see Azure Kubernetes Service clustered user role. So Azure Kubernetes Service cluster user role, so that your own account can download the credential. Clustered admin, so you can create the namespace, deployment, service, support, event, everything. Right, assign the roles using the Azure portal. So these two roles we need to assign. So again, the same process you need to follow. So again, go to this access control, add role management. So this time, this is Azure Kubernetes Service. Again, the same two role you can see. This is role, select nation. This time, what I need to select? I need to give permissions to my own account. That one account means it is a user, not a managed identity. User means this option you need to select. Click the select button. So currently you can, this is the signed in user. Select the signed in user, give this permission and assign that particular user. Second role, what we need to give, cluster admin access. Admin access, see, in previous case, we are giving this RBAC writer so that they can do operation on these resources, but they cannot create these resources. Admin means what? Admin can create these resources, admin can update these resources, admin can delete these resources. That is the reason why we need to give admin access. So now go ahead, select this one, admin, RBAC cluster admin, select next, select the member, select the signed in user, select this one, review assign, again review assign. That means we have given all the required permissions to the user. Okay, clear guys? Clear or not?
Yes,
Till
sir.
now. Okay. So once this is done, right, now you can check whether the cluster is working or not and everything, right? So how you can do this? So this is optional. So just verify. So this is my cloud shell. You can see connect. So in this case, sorry, okay, requesting a new cloud shell. It is connecting terminal. So now in this case, I'm using my own account. Okay. So first of all, what I need to do, I need to say, right, the account. I mean, what account are there? So clear this window. So how many Azure accounts, I mean subscriptions are there? Only one subscription is there. That means only one subscription means that subscription is by default selected. If you have multiple subscription, you can select right on which subscription you want to work. So that using this command. Now you can see that the credential, right? So we have given one permission. What is that permission? This permission, right? Clustered user role. So this permission will download the credential and update the quick config file, right? And now let us proceed and see whether this syntax is working. So here you can see get credential, right? From where it will get the credential, from this resource group, and within this resource group, it will download the credential for this cluster. And if already any config file is there, which is containing some old configuration, they are going to be updated. So this is what we are writing. So once this command is executed, right, then only you can perform the Azure CLI operation. That means now Azure CLI authentication is enabled. So now you can perform operation. Perform operation means what? You can see whatever services is there within the cluster, how to create the deployment file, how to update the deployment file. Anything you want, you can do from this command prompt. But here we are not going to use this command prompt. So what we need to do, we need to verify. Right? What we need to verify? We need to verify within this cluster how many nodes are running. So how many nodes are running currently? Guys, tell
Two.
me. So if you
Two.
go to node pools, so how many nodes are there? Two nodes. So now let us see the same thing here also. So the same two node is there,
Yes.
right? So that means our cluster is also running. Now what is the important part? The important part is the manifest. I mean what? We need to create the required resources within the cluster. What are the resources we need to create? One is namespace. We have already discussed why. Now it is a logical container for the related resources within the cluster. Deployment means this is the instruction. Instruction means what is the where the what a image to be used, how many number of ports to create, what the environment this is the application is going to be run, what is the update strategy, what resources you need to use. So those instructions we need to provide using the deployment. And this load balancer service means what? Now this is going to provide the public IP using which the client or external world can communicate, and it will map that request to one of the available port that is running within the cluster nodes. And how we can create? Now you can create this right resources right by going through these steps, right? So we'll see how to create this. So let me start with this one by one. So first of all, I'll create a namespace. We have already discussed what is namespace, how to create namespace, all these things. So I'm not going to give many right focus to this concept. We have already discussed this thing in our AKS session. Now, so from here, right, you can see there is something called Kubernetes resources. So I'm currently in my cluster. So click on the service and ingress, and here you will find one option, apply YML file. So in this case, once you open this one, paste this code. So basically, we are creating a namespace, right? That namespace name is product management, and I have provided some right label, right? What is the name? Product management API environment, whatever you want, you can give. So these labels are optional. Now click on the apply button, so that namespace is created. You can verify that namespace by going to this namespace tab. So here you can see this is product management namespace. Some other default namespace, if you have not created any namespace, whatever you created remaining resources, they will be created inside default, right? And these are some system generated namespace for internal purpose they have already created. So this is our namespace, and within this namespace, our deployment as well as our service we need to create. So this is going to be our deployment file. Okay. So basically, let us have a look. So basically, we have created this as a deployment so that it can contain the instruction to be used by Docker to host our application. You can give any name, and this deployment is going to be created inside this product management namespace. Some unique identifier, right? A product management API. So you can easily filter this namespace based on these levels. So how many replicas we want? We want two replica. Then revision history limit means it will keep the last five deployment history, which we can use for the rollback of purpose. Strategy, it is going to use rolling update. So it will not stop any existing pod. It will create a new pod, and once that new pod is running, then it will stop the existing pod. And accordingly, so never your application is going to be stopped. Always, right? It can always you can say online. Online means anytime you send a request, definitely you will get the response. So matching label. So this is the label that we can use to match the selector. Right, then this is the template. You can see some additional information about the what I can say uh, about this what I can say workflow or not workflow, about the deployment. So what is the name? Product management API, some So basically, some initial information you want to give to the deployment, that what you can give. So these are also again labels. So this container means this is how container means this is where it will download the image from ACR. This is where it will create the Docker right container. It is where it will run that container inside a pod. It is where it will assign the port number and everything. So first of all, you can give a meaningful name. Any name you can give. This is nothing but your container name. Please remember, this is going to be the container name. So then what image you need to use? This is the latest image, whatever available. See, currently I'm hard coding this with the latest image. Later on, I will show you how it is being updated. I mean, how you can use always the latest version using the I mean that hash number from our workflow. Image pull policy, always it is going to pull the image from the, what I can say, repository. So port means container is going to be run inside this 8081 port. Environment is going to be development. So here I'm using some red probe. So you can go with the start probe, readiness probe, liveness probe. So whatever probe you want to use, we have already discussed. And here for simplicity, I'm using only one probe, which is going to invoke this endpoint. And if this endpoint is ready, then your application is ready. And this is the resources. So this is the CPU, minimum CPU, and the maximum CPU is maximum CPU a pod can utilize. So this is what we need to give. And what we need to do, again, go to the service and ingress, create a new YML file, paste this one, apply this one, and now you can verify the same within the workloads folder. So in the workload, you can come to here. So currently this is running. You can see it is not yet completed. Okay, now you can see ready. So that means what? Now your cluster is ready. Okay. So deployment is done. Now what I need to do, I need to create the service. Service means we need to provide a public IP to our services. And for that purpose, we are also going to create a service. So again, select this one, YML file. I'm not giving more importance to this thing because we have already discussed this thing in our AKS sessions. So the kind is going to be service. So it is going to be service name. You can give any name. Namespace you can give label, same label what we provided earlier. So the service type is going to be load balance so that it can receive the request and it can eventually distribute that request to the all the available nodes. So this is the selector. Using this label we can select this service and it can receive the request on the port number 8. It will forward that request to port number 8081. And if you remember, 8081 is the port number we provided to the container. So it will receive and it will forward that request to this port number. So click apply button. So once this is done, so what exactly it means? Now our application is running. So how you can verify your application is running? So now if you come to this service, so within the service, you can see your product management. So it is in pending state. Come here and see whether it is completed or not. Okay. Now you can see that external IP address. So this is the external IP address. Click on this IP and then type further. Okay. That means our application is now fine and it is working in Azure Kubernetes Service. Till now, whatever we discussed or whatever we done, this is manual deployment. Now what we need to do, we need to make this implementation with automation. So now the Azure side preparation is complete. Azure Container Registry already exists. The user assigned managed identity exists. GitHub OIDC Federation is also configured. Managed identity can push to image to ACR. AKS cluster is running. Kubelet identity can pull image from ACR. Product management and namespace exist. Kubernetes deployment and load balancer service exist. The CI/CD managed identity has permission to connect AKS, update the resources in the namespace. So this is what we have already discussed. So now what we need to do, we need to implement our what I can say CI/CD pipeline. So to implement the CI/CD pipeline, what we need? We need to go to the GitHub site. So open the GitHub, go to all the repositories. On which repository you want to implement the CI/CD pipeline? I want to implement in the product management API. So in the product management API, right, you can see the workflow. So currently, this workflow we have created yesterday, and I have disabled that workflow. So if you want to delete, you can delete. Currently, it is in a disable mode. So now if you go to this one, if you select this one, currently it is disabled, means what? This workflow is not going to be run. Yeah, intentionally I have done this. Why? Because I'm going to create the workflow which is going to do both tasks. That will implement the CI pipeline as well as the CD pipeline. That means what? That means that workflow is going to have a two different job. One is build, push, another one is deployment. So all these things we are going to do within a single workflow. So before that, what we need to do? We need to ensure the required configurations. And I have already implemented this. So if you go to secret and variables, so here you can see the secret. So this secret Azure client ID, Azure subscription ID, and Azure tenant ID. This is already there, right? This is already there. But do I need to use this client ID, subscription ID, and a tenant ID? Yes. So this client ID, subscription ID, tenant ID, we have already created. Now, what is important? Important is the variable section. In the variable section, right, please figure out how many variables are created. So earlier, what we have discussed, earlier we have these three variables, ACR name, ACR login server, ACR image. Now what I have done, I have added a few more variables. What is the resource group? AKS resource group. So here you can see I have created one AKS resource group, Azure Kubernetes Service resource group. This is my Azure Kubernetes Service resource group. So few more variables I have added. How you can add? Click on this button, new repository, give the name and give the value. Like this you can add. And what all variables I have added? ACR login server, ACR name, AKS cluster name, AKS resource group, image name. Image name means, guys, remember this is going to be the repository name within the ACR. Then this is the container name. We have given this name to our container within the deployment file. So this is going to be the deployment name. Okay, let me show you this thing practically so that you will understand. So now I come to here. So this is my workload. So this is my product management. If you go to this YML file, so this is not, this file is being updated. Okay, not this one. So here you can verify, right, whatever the deployment we provided, right? If you go to the container, this is going to be the container name. So that what we have provided here. So container name, deployment name. If you come to here, that the deployment name means clustered workload. So that deployment workload, you can see deployment. This is going to be product management API deployment. So this is going to be my deployment. Similarly, namespace name, if you come here, then that namespace we have provided is product management. So that value I have provided also here. So if you come to here, so that product management and service name means if you go to service and ingredients, so within the service you will see this is going to be my service name, product management API slash service. So all these variables I have added. Clear? Clear, guys?
Yes.
Yep.
So, right. So once this is done, next what I need to do, I need to create the complete workflow. I need to create the complete workflow. So let me go ahead and do this thing. Okay, this is going to be little big. So this is going to be my workflow name that will be visible in the GitHub Actions. This workflow is going to be run when we push the code to the main branch. Also, we can run the workflow manually. We have given the read permission so that we can read the repository content to the runner. And we have also given this ID token right formation so that GitHub can generate one IDC token. So these are the variables that what available, right? Image name, build context, right? Resource group, cluster name, namespace, deployment name, container name, and a service name. So this is what we have already assigned, where we assigned within the uh, variable. I mean, within the GitHub repository variables, this is the Docker file path where the Docker file, I mean, this is the Docker file which contains the instructions how to generate the image. Build context means this is the folder which contains all our application source code. So there are two jobs we are going to create. One job build and push the Docker image to ACR. And this is very similar to the job what we created in our last session. First of all, it will download the repository source code. Second, it will authenticate GitHub Actions with Azure. Third one, it will request a temporary access token. Fourth one, it will authenticate, right? Whatever the access token it received, it will authenticate that will authenticate Docker with the ACR. So once the authentication is completed, it will use this buildx to build the Docker image and push the Docker image to the Azure Container Registry. And while pushing, whatever GitHub.sa means what? That what I can say that SA value of the commit that what it is going to push along with the one tag. So this will become the tag and this will also become another tag. So basically two tags it is going to the same image with two tag it will push to Azure Container Registry. So this job is done. The second job is deploy the image to AKS. So so the first job it will push the image to ACR. Second job we need to deploy the image to AKS. So how we can do this? So whatever the name you want to give to for this step, that is fine. Again, this step is or this job is going to run within a Ubuntu machine. That is also fine. This is important, guys. So this job is only going to start when this build and publish job is completed. So if you remember the first job name, right, what we gave build and publish. So once this build and publish job is done, then only the second job is going to be start. So this deploy to AKS job is only going to start when the build and publish job is done. Again, what we need to do, we need to authenticate with Azure using the OIDC token similar to job one, whatever we do. Then we need to install the kubelet and kubelogin so that using the command line, right, or you can say bash command, we can log in. The third thing is we need to retrieve the Azure credential, right? You can, you know this command, right? Executing this command will download the credential to the ready kubeconfig file. Then we need to configure the kubeconfig file so that we can execute Azure CLI command. Then we need to verify the connection to the AKS cluster. So how you can verify if we are getting the nodes, if we are getting the namespace, whatever we specify, if this namespace and if nodes are running, that means our connection is fine. If we are not getting any information, anytime any statement is failed, then it is going to stop the right, what I can say workflow. Then we need to prepare the complete image reference. So this is going to be whatever the login server, whatever this image name, guys, is nothing but your repository name. And this is how we push the same github.sa we need to use so that we can get the full image. And that full image we are also logging into the logging so that we can verify. Then we need to update the Kubernetes deployment image. So basically, if you remember, this is the container and this container using this statement. So this is nothing but our deployment. Within the deployment, we are using this image. And what we need to do within this deployment file, we need to update this image with this folder. Clear? And how we can do this? By using this kubelet command, we can write update that particular image. So once the image is updated, then what we need to do? We need to update the rolling update. We need to write a deployment our application means roll out to deployment. Rolling update it will do. Rolling update means it will create a new pod. It will once the new pod is created, it will stop one of the existing pod. It will create another pod again. It will stop the existing pod. So that rolling deployment is going to be happening. So once the deployment is done, then we need to verify whether, see guys, remember these verification steps are optional. If you want to verify, that is well and good. If you want to skip, you can also skip. So whatever the image we configure, whether that image is deployed or not. So that's what we need to verify. Expected image and then the actual image. So this is the expected image, means what we are expecting, and what image is deployed. This command will give you that image name. So we need to compare this expected image and the actual image. If right, that is compared, that is fine. If not compared, we can exit, means we will not execute the remaining statement. From here we will display this message. Verify the Kubernetes deployment, which deployment file is being used. So this command will give the deployment name. This command will give me the application code which are currently running. This command will give me the replica sets, right? How many replica sets? And this command is going to give me the service name which is running. So this is going to be my what I can say uh, file. So guys, most of the time as a developer, we are not really bothering what syntax have been written. This is one time. This syntax is always going to be same. You do not need to, if you want to change, then you only need to change this. What is the ACR name? What is the ACR name means the ACR name, not the ACR login name. So that's what you need to understand. Here, ACR login server, whatever the key you are using, that what you need to change. Remaining thing is going to be same. Guys, give me 1 minute. Okay. So then, what we need to do? We need to create one file. So what should be the file name? So you can give any name. So in this case, I'm going to give the file name as CICD So any name, AKS CICD So how to create this file? Okay, come to your code workflow, add file, create a file, name this one AKS CICD workflow. Copy this code and paste it here. Okay. Commit these changes. It AKS CICD pipeline create. Commit these changes. So now go to the Actions tab and see whether this pipeline is running or not. It is automatically started. So let's wait for some time and see whether it will complete these two jobs successfully. One job responsibility is to create the image and push that image to Azure Container Registry. Another job is responsible for pulling that pulling the latest image from the ACR and deploy that image. So let's wait and see whether these two steps are completed successfully or not. So meanwhile, guys, two more sessions I will to explain the unit testing concept, and after then our syllabus mostly is going to be completed because many things initially I have not planned for these things. For example, I have planned only 2 to 3 sessions for Azure. I only want to display one option, that is how to deploy the application into Azure Kubernetes Service, 1 or 2 days. But I think I have taken more than 10 sessions. Similarly, initially GitHub Actions, CI/CD pipeline. I only planning to display only implement only one CI/CD pipeline, but we have created so many things. So CI/CD pipeline with the on-premise services, CI/CD pipeline to Azure App Service, CI/CD pipeline for what I can say. So here the deployment is failed. Let's see why. Right, so here you can see user doesn't have access to the resource in Azure. Update the role assignment to allow access. So basically, what exactly it is telling? So currently, whatever the user we are using, he doesn't have access to the cluster, but we have given permission. So let us verify the same thing. Right. Okay, let us, I mean that AKS permission is missing. So let's see where it went wrong. So this is fine. This is also fine. Kubelet identity permissions to pull ACL. So to this user, we need to give two permissions. Azure Kubernetes Service, clustered user role, Azure Kubernetes Service, RBAC writer. Okay. Kubernetes services, access control, role assignment, right? Okay. Let me check this role is given to whom. It's fine. This rule is also required. Check this one is given or not. This is also given. What is this role assignment error? What I'm getting? Let me check my right container registries whether that deployment is done or not. This is fine. This is also fine. So which role I need to give? Assignment we have already done. Then why I'm getting this error? Well, let me do one more thing. Let me check whether issue is something else or this one. Okay. So function testing, then pull the changes, then push the changes. So whether it is working this time or not. Ideally, it should work, but I think we have missed some particular role. Assign user role as Let me remove this and see.
We are getting issued number 5 only, sir.
Right?
We are getting issued number 5, step 5.
If there is some issue, right? Getting this node information and all these things. I don't know why it is getting failed.
Community has mentioned number 5 only. Yes, we have run set TCO 5 file.
While you were assigning the roles, right, in the Azure, it was showing some role assignment was filed notification.
Because that role was already assigned. That is the reason why that going.
Not now, before also. I mean, before first time you were assigning, right? Maybe in the history you can check notification.
I think this time it works. Okay, job completed, right? I don't know what is the issue in that particular statement. You can remove this part. Okay, fine. It's fine. So now, once this is done, right, you can see that completed. Now verify whether, right, the newly added endpoint you are getting or not. So refresh this one. At that endpoint I'm getting, that means it is working fine. Clear?
Yes.
So you can change this to step 5. It is going to be your step 6. This will be your step 7. This will be step 8. This will be step 9. And this is going to be the step 10, step 11,
Great.
step 12. Yeah. So now it's working. So basically, whatever the changes we have done, that is deployed to your right Azure container. So you can also verify the newly created image. So this is the newly created image. Now, in the deployment, you can verify what is the image name. So that product management container, this is the image name, right? D13C5. And here you should see that image. Sorry. D13C505. So this was earlier we created, right? Okay, let me come to this part.
Yeah, it was there in the second one.
Yeah, second one. It was in the
One.
beginning. Yeah.
Yes, yes, this one. Right. So this is the image that is being deployed. You can also verify the time, GMT time. So it's working. Clear?
Yeah.
Okay. So guys, right in our next session, we'll discuss unit testing.
Sir, can you have a versions for this deployment, sir?
Right?
Can we have a versions for the deployments? Suppose initially I was created one deployment. After some days, I got some enhancements. I want to maintain the version 2 because anything happens. So I want to roll back the version 1. Like that, is there an option is there?
Yeah, so basically, rollback means what? So you need to roll back the changes from your right main branch, right?
Version 1, version 1. I want to roll back. I want to, if any issues are coming in version 2, so I want to, previous one, I want to execute the version 1.
Yeah, so that's very simple. So you want to do that manually or automatically, first of all?
Any case, either
Yeah,
automatically or
so yeah, it's very simple. Just update the right file and whatever the version you want to use. So instead of right generating that, just update that image name. That's it. So here we are specifying that image name, right?
yes.
So this is the image name. So instead of latest, which version you want to use, that's what you need to specify. Second option, if anything went wrong, what you need to do, you need to roll back your changes from the main branch in GitHub. Once you roll back the changes, again, that is also going to hire one more, what I can say, operation. I mean, it is going to also do the same thing. Whatever your production, whatever your main branch content, that will automatically going to be deployed. Yes, if something went wrong, you can also manually roll back to any of the branch. For example, right here, if you look at this, so you come to uh, Azure Kubernetes Services. So this is your Kubernetes services. You figure out which branch you want to roll back. That's what you know. What is your image you want to update? Just go to this service and ingress, and here, sorry, workload. And in workload, you will find this deployment file. Just come to the YML file and update that image. So currently it is not showing, but you should have that image file, right? That service file. For example, you should have that deployment file now,
Yes, sir.
right? So in this case, you just need to update that image. And once you update, then just do your right rolling update automatically. Whatever the image you specified, that will be deployed. That is very simple, and we have already discussed this thing. I'm not discussing this thing. Why? Because that rolling deployment update, all this thing we have already covered, right? So we have already discussed this thing in detail. Where is your part 18? We have already discussed this thing. Rolling update, how to update to a specific version, everything. Roll back to a specific version, how you can do this thing, right? So it is also maintaining the version history. So all these things we have already covered. Clear, guys?
Yes, sir.
Yeah, roll back a failed release if something went wrong. If not fail, if you want to roll back to a specific version, that was also possible. Because it is maintaining 5 versions of the image. Or mostly, if you are having that Docker image, you can easily roll back to that particular Docker image. Okay. So, guys, if possible, tomorrow we'll discuss unit testing. Thank you, guys. Yes,
Hello.
yes, please.
Panay, in a syllabus, we have also Grafana, Prometheus. Have we completed or is it
Sorry.
in a syllabus we have Prometheus and Grafana monitoring tools?
The monitoring tools, I think we have already covered.
Okay.
The only thing what is remaining from my side is Kafka. That what I will discuss later. So Kafka I will discuss later, but first of all, I will complete this. Right, see, the monitoring tools means Azure monitoring tool. It mostly, right, you will get clarity in Azure session. Because if I'm going to discuss, that will be possible. I can discuss. But to understand those concepts, it needs time. Time in the sense, right? Currently, first of all, let me complete that microservices. And once I discuss those concepts in Azure, I can allow you guys to attend the sessions.
Okay.
Yeah, some Azure service bus as Azure mesh, right? Service mesh, Azure functions, right? Many things are there in Microsoft Azure. And discussing all these things is not possible.
Okay.
Okay. Yeah. Because see, if I'm not covering this concept in detail, then I can cover those concepts. But as we are taking Azure initially, I plan to plan for 1 to 2 sessions. Okay, let me show the syllabus. So you can see CI/CD pipeline for microservices. Initially, only one session for this one, but I have discussed multiple options, right? And here load balancing we have discussed. Kubernetes, right? You can see only Kubernetes basics was there, but we have discussed all the concepts related to all the concept related to Docker, basic concept of Azure, Azure App Service, Azure Container Registry, Docker image, how to do all these things, right? Many things we have covered. But yes, some things are missing, but right, I'll cover them in Microsoft Azure session. And at that time, I will allow you all guys to attend those sessions.
Yeah, sure. Thank you.
Okay. Thank you, guys.
Thank you, sir. Good night.
Thank you.
Thank you, sir.
Thank you.